Today we're going to talk about centripetal force. Centripetal means center seeking. So guess where the centripetal force points? That's right, it's directed toward the center. So let's break this down. What must an object do in order to turn? Well, turning means that you're changing direction. And if the object is changing direction, then the object is accelerating. We're going to use some examples from the ladybug simulation to help us out today. Turning requires the acceleration vector to be directed in what direction? Well, let's look at the ladybug from yesterday's simulation. Notice that as the ladybug turns, acceleration is directed toward the center of the circle. Well, in which direction is the velocity vector? Again, let's look at the ladybug. Notice the velocity vector is pointed directly in front of the ladybug. It is said to be tangent to the circle. Well, looking at the diagram, how are the acceleration and velocity vectors directed relative to each other? Hopefully you notice that the velocity and acceleration vectors are perpendicular to each other. Now let's examine these two questions. These were on the ladybug simulation paper. If the table is turning clockwise, sketch the velocity and acceleration vectors. And what if the ladybug gets too close to the edge and flies off? Which way will it go? In this diagram, if the table is turning counterclockwise, then the velocity vector will be directed as such, and the acceleration vector will be directed toward the center, as it always is with centripetal acceleration. Now let's look at if that ladybug gets too close to the edge and the table is rotating counterclockwise. Let's draw the velocity vector. Whatever direction the velocity vector is pointing, that's the direction the ladybug will go. So the ladybug will fly off in a straight line that is tangent to the circle where it left the table. Centripetal acceleration is found with the following formula. AC, for centripetal acceleration, is equal to v squared over r. Centripetal force can be calculated with F equals ma, where the centripetal acceleration is used. That gives us an equation that looks like this. F is equal to mv squared over r. So of course, let's do an example. Tyler is running with a speed of 10.6 meters per second around a curve on the cross-country course. If the radius of the curve is 12.7 meters, what is the centripetal acceleration of Tyler? As always, start by writing down what you know. V is equal to 5.6 meters per second, R is equal to 12.7 meters, and centripetal acceleration is what we're looking for. Write down the equation for centripetal acceleration, plug in your values, and put it in your handy-dandy calculator. You should get a centripetal acceleration of 2.5 meters per second squared. Now let's look at the second part of the example. If Tyler's mass is 72 kilograms, then what is the centripetal force acting on Tyler as he runs? Again, start by writing what you know. You know the mass is 72 kilograms. We just found the centripetal acceleration to be 2.5 meters per second squared. And of course, F is equal to ma. Plug in your values, put it in your handy-dandy calculator, and you should get a centripetal force value of 180 newtons. And voila, you're done.